Kukreja, working as a PhD scholar in IIT Tirupati. So let's start our week 3. I hope so. Till last week, everything is clear to you. Let's start. So we'll try to cover these linear regression, multivariate regression, the shrinkage methods, and the Lasso, ridge regression, TCR, and the other one, partial least square today in this today's lecture. Sagnik, I'll come to those questions afterwards. Like we'll discuss these at the end of the lecture. Okay, let's start. I'll not rush again, but I'll try to cover at least week 2 today. So any idea, like we have discussed what is linear regression, and so any idea, can someone tell me in brief what is linear regression? Yes, come on. Okay. Please mute yourself if you're not having any doubt. Otherwise, in recording also, people will face issues.
We are drawing a line that is supposed to encapsulate most points in a drawing a line to describe a function.
Absolutely. So drawing a line like classifying or a regression. Regression means it's numerical. So basically drawing the line so that we can separate and all the way we have understood in the previous first lecture only. So this is the equation. I hope so. This is discussed many times. Yeah. So is it clear?
Yes.
Can someone explain me? What is beta naught?
Beta naught is the
parameters, model parameters.
That is the intercept.
It is the intercept. Yeah.
Yes. So someone asked me in the first lecture also why we need this. How unmute yourself only if and only if, like, if you are having any doubt, please don't unmute yourself, otherwise there's this like there'll be disturbance in the class. Okay, yes, you were saying beta naught is an intercept. What about the others one? What are xj's or x here?
Xj is inputs.
And with xj, bj, we see how much our x is changing with 1 unit.
Okay. So as you said, beta naught is a intercept. Absolutely correct. So what is the role of beta naught? Basically, they move up or down. Like from it's not like shift. I'd say maybe we'll discuss more. Like from where to start, whether from origin, from upwards or so. That is the role of this beta naught. The same as intercept role in the line equation that is there, and this xj and beta j, though I hope so that you all know about this features and and what is this, how we'll get to know this beta j. This is what we'll try to understand, how we'll get to know about this coefficient. That is what we studied in the first lecture also, like these are the coefficients or these are the weights which we have to actually find out, that how much weight should be given to one input parameter. Like I gave you this, and then I gave you and I told you which one, which feature is most important. Can you tell me?
x3.
X3, because it's having the highest weight or it's having the highest coefficient. So it's having the highest beta j. So that's why it's more important. So we have to focus on that one. So this is the role of these weights, and these are the input or the features, input features basically. So sometimes there is a issue, like, so though I'll not go in detail with the basis expansion, though sometimes I have some variables and I like a non-linear one, and I want to convert into linear regression. I want to fit linear regression. So that transformation of them to make it more like, suppose I have y is equal to x square, I add this 1x x square, or so this is called basis expansion when I'm transforming this input so that linear regression can be applied here. Though I'll not go in detail of this basis expansion. Maybe in future we may study about this basis expansion, or if you want, we can study. So this is just a brief, like, okay, we can add some variables or some features to so that linear regression we can apply on it. Nothing else. Don't worry about this. Now, if I have qualitative input, the other thing. Qualitative input means big, medium, small. So there is some qualitative, hot or cold. There are some, I'll say levels, or if I don't have levels, suppose red, green, blue. So how to do the how to do this in coding or the regression part? Anything, anyone can tell me? What we have to do with this if I have qualitative input? How can I handle these qualitative inputs in my linear regression?
Classification. I mean,
Anyone?
You have to use encoding.
Encode. What is encoding?
For each output, we have to use some bits like binary.
So
If it is binary 1 or 0, or if it is one hot encoding.
exactly. So someone told me that there can be binary encoding as well as one hot encoding. I think there was a question in your assignment as well. Have you answered it? Like I saw this that one. Like what is this binary encoding and what is this one hot encoding? Can someone tell me? Suppose I have 4 colors: red, blue, green, and orange. So what if I want to do this binary encoding, and what will be if I want to do this one hot encoding? Can someone tell me?
Using two binary bits, we can have 4 combinations. So that will be binary encoding.
What about one hot encoding?
For each colors, we will give 1 bit. So 4 bits we use for 4 colors.
Absolutely. So suppose I'm giving the first bit to the red one, second to this, third to this, and fourth to this. So what I'm doing is binary encoding means I'm giving I'm using this 2 bits basically. One hot encoding means for like first bit I'm giving to red, second bit I'm giving to blue, and third bit I'm giving to green, and fourth bit I'm giving to orange. So what are the advantages and disadvantages here in both of them, binary and one hot encoding? Anyone? Are you clear with this concept or not? If anyone is having doubt, please ask me.
it is easier to perceive one hot encoding, but binary encoding takes lesser memory.
Absolutely. It's easier to perceive one hot encoding. There is less interference there in one hot encoding, obviously, as we are giving 1 bit to each of them, rather than giving the same bits. Like here, if I see red and blue, the same bits are given. The same bits may be given and are given actually in binary one, but in binary one, as you said, that memory is basically concerned. Absolutely correct. So now coming to the main part. I have the training data. I want that linear regression should be clear to you because it's the base. It's very important. So please listen to it properly, like how the things are. So as we know that this xi, we have discussed what is this xi. This belongs to a real number. These are the input features. How many features are there? This is input feature vector. How many features are there? Anyone?
P feature.
P features, absolutely. So let's take an example as well, so that you can like side by side, I'll give you an example so that you should be clear with the concept. So suppose, let's try to understand with this example. I have data point I have feature 1, feature 2, and target Y. So this can be written as xi1, this can be written as xi2, and this can be written as yi. I here is data I. First data point, second data point, third data point. Suppose this features are 2, 1.54, 3.52, and 1. So now, suppose now what we are saying, this training data, it can be written as like this. So how I have written xi1, xi2, is it clear? Or the same way I have written, clear? Should I proceed?
Yeah.
Simple?
चाय बना रही हूँ चाय की फोटो
Simple? Should I proceed?
Yes, ma'am.
Now, the second step. I have taken, this is the training data. You got to understand how I have written. Let's take least loss, or in other words, what we call it as residual sum of squares, RSS. So my main motive is, first of all, I'll write it as RSS. Can someone explain what is it I have written? Maybe I'll increase the brightness. Yes. What I have written actually.
Error square.
Error square. Basically, yi is my target one, fxi, which is the predicted one, and the loss sum of basically least square loss, the square of the loss function, the sum of the square of the loss function. That is what I have written. That is also simple one. Now, can someone tell me how I have converted to matrix function, like matrix form? Can someone tell me?
You never gave the value of y, ma'am, but what I can see is that you've taken beta and you've multiplied it with every value in x, and then you took that y minus this, and then you took a transpose into that.
Or one more thing. This fxi, what is this fxi? What is the value of fxi?
Beta naught plus.
Can I say this is basically equal to xi transpose beta, yxi transpose beta? Okay, I'll go very simple. Okay, leave this matrix notation. I'll come to this matrix notation if you are having any doubt. Let's start from this one. RSS is this, yi target one minus the predicted one. And how we are calculating it, we know that through the linear regression, how we are multiplying this x into beta. Y transpose, let's try to understand and how these things are going. If I talk about xi is column vector. We have seen, as we have taken the transpose thing, we have seen this xi. This is a column vector. What is the dimensions of this column vector? Can someone tell me?
2 cross 1.
3.
No. Generally, not about example. If I have
3. three data points, 3 dimensions.
No, not
Three
about this
dimensions.
3 dimensions. Okay, the 3 dimensions. If I'm taking intercept, then
P
can I
plus 1.
plus 1? So can I say P plus 1 cross 1? Am I correct? This is matrix na, column vector na. So P plus 1 rows cross 1. Am I correct?
Same.
Beta is also column vector. Which is having P plus 1 cross 1 dimensions. Now, obviously, I can't multiply it directly because P plus 1, if I talk about this matrix or like multiplication, I can't do it. So I have to do xi transpose so that to multiply this, both of them, x into b. Now, does it make sense why I'm taking why I'm taking transpose? Now, if I do this 1 cross P plus 1, multiply by P plus 1 cross 1, so I'll get the scalar. Result will be scalar. Fine. Any doubt? Ask me multiple. Yes, come on. Now talking about capital X. Capital X is, this was the simple P plus 1 I am taking features. Now capital X is all of the X's basically. This was 2 and 3.5 X1. Now I'm containing X1, X2, X3, all of them. Which means N, how many? Like here it was 3 cross 2 basically. Here it will be N cross P plus 1 matrix. Clear? Yes, come on class. Is it clear?
Ma'am, what is the N?
Yes.
Capital N, ma'am?
The number of here I have number of data points basically. Here I have 3 data points, 2 features.
Okay,
Number of
ma'am.
data points. Here I am having n number of data points. I don't know. This was just a toy example. Na? 3 I am taking. Here I am taking total number of data points into p plus 1. So like it will be, if I talk about capital X, it will be 2, 3.5, 1.5, 2, 4, 1. So n rows multiplied by p plus 1 features.
Ma'am, what do you do after P plus 1 xi?
Where?
Yes, ma'am. This column vector.
You're asking about this?
Yes, ma'am. What did you do after this?
This is p plus 1, not xi. This is p plus 1 multiplied by 1, like 3 cross 4 matrix. Similarly, what I'm saying is, p plus 1, I'm having the rows, whereas the columns are basically, this is a column vector. Like this. How many features are there? P plus 1 features are there, 2 and 3.5. And how many rows are there, how many columns are there, as it is a column vector, so multiply by 1. Why I'm taking plus 1? Because I'm including intercept here. Clear? So now if I'm taking all the data points, so rather than 1, I'm saying n cross p plus 1. It was only of x1 or x2 or x3. Now if I talk about all of this, so I have n data points, so n cross p plus 1. Clear?
Yes, ma'am.
What about others?
Yes,
These
ma'am.
steps are very important. So that's why. So usually we call this as design matrix. The whole X, the features and everything. Now, where each row, as we know that each row is this. Now, X is n cross p plus 1. Beta is p plus 1 cross 1. So what we'll get, n cross 1 as y. Fine. Fine. This is our 5. This was the simple xi case I was telling. Now I'm talking about whole design where whole data points are considered. Now coming to RSS thing. There I have I'll write this in first. Not in matrix notation. Let's see RSS. residual sum of the squares or the loss function in the matrix notation. So we have discussed already this. And we know that Fxi is equal to xi transpose beta. Done. Now, when we usually write, square. When we usually write this V transpose V, or I'll say when I multiply this V1, suppose I'm taking the example, toy example only. V1, V2, V3 till Vn, these are the vectors. And this is V1, V2, V3, which means what I'm doing is V transpose V. The same, this is a V vector and this is a V vector, what I'm doing transpose. So what it is equal to V1 square plus V2 square. This is an example just I'm taking so that you should understand. Vn square. This is what I'm getting. If I'm multiplying V transpose into V, a row matrix and the column matrix, like a vector with its transpose, I'm getting this, correct? Which is equal to the sum of like square. So which means that I can write it as, so what it is basically the sum of the V1. So I can remove this sum of the square. I can write 1 by 1. I can write it as yes, now speak. Yes. This is how I got this in matrix notation. Yes. Someone was speaking, yes. I'm sorry to interrupt. Any doubt? Come on.
No.
Why the voice is so low? You heard me.
Oh, ma'am.
So
I
y
guess.
is the output, x is the input, beta is the intercept. In your, let's say if we get a question, or let's say we got a set of data, we got the input, we got the output, and we have to find out beta. Is that right?
I'll come to that. Don't worry. I'll come to that how we'll find the beta also. Till now, how we are going, I'm just, what I'm trying to do is like, these steps, basically, these are not told. Like, they are just, like, so I'm basically pinpointing how we are coming to each and every step, by how we are jumping to it. So that's what I'm trying to explain from very basics. Once again, I'll tell you. Nothing I have taken, just this is just the base I'm making. I'll come to how we'll come to beta, how we'll find out beta. Just I have taken the training data. Sorry. Just I have taken the training data. Then what I have said that, okay, how I'm representing this training data, that I have tried to explain you. Then we came up with this, like how we are basically representing xi's in the matrix form. Like I have p plus 1 I'm taking because of the intercept. How I'm representing, so it may be like if I have n number of data points, it's like n cross p plus 1. And the beta is also p plus 1 cross 1. So it's like y is n cross 1. And how we are writing this in the matrix notation, whenever we do the sum and the square, so we can write like this, the transpose into transpose. Like you can see, the vector multiplied by its transpose is nothing but square of its sums. So that's why we can write it as like nothing. Just have a
Ma'am,
sum.
one query.
Yes.
Ma'am, if we here you have considered ya minus x beta as v, right? So that xi transpose should be there, right? Xi transpose b, the inner transpose.
This one. This I have taken this v. I'm not considering this whole is suppose v. I am saying.
So this in the final result now, when you write, it should be yi minus x transpose beta whole transpose, right?
X beta transpose. Okay, 1 minute.
There.
I'll tell you. So x is equal to xi transpose, x1 transpose, x2 transpose, xn transpose. Or I'll say x beta is equal to x1 transpose beta. Can I say this? X is equal to this. Now is it correct? Now can I write it as X?
Okay, okay. Yeah,
Sure.
you multiplied it with the beta.
Mhm.
Okay.
Just what I'm doing is representing this X side, this just representing this X in the form of X side transpose rather than X1, X2, X3.
Got it, got it.
Why? Okay. Let's try to understand this also. Very important point. I'll come to this. How I'm representing this, I forgot to mention. Very important. Thank you for pinpointing me. So, as I have told you, this X is equal to N cross P plus 1. And we have also done that, what is this Xi transpose? Xi is basically P plus 1 cross 1. This only we have done. So we have also done that Xi can be represented as, like, suppose 2, 3.5 in our example. I'm just picking the above things and mentioning here. Fine. And here, what I'm saying is this is X1, X2 is basically 1.52, and X3 is basically 4. But when I'm mentioning X, what I'm saying is it's N cross P plus 1. How I'm saying is, what I'm saying, X is equal to Xi transpose. Xi transpose means, first thing is, like, here I'm mentioning 1 because of this intercept. Xi transpose means 2, 3.5. 1.5, 2, 4, 1. Clear?
Yeah.
Does it make sense now? That is why it's N cross P plus 1. And it was this P plus 1 cross 1.
Okay.
Thank you for pinpointing. So that's why here it's the transpose is missing, because X itself is equal to Xi transpose beta. X beta is equal to Xi transpose beta. Any doubt till now? You got how the professor is going to matrix notation? What are the steps behind those things? Fine. Should I proceed?
Yes, ma'am.
Wherever you have doubt, please stop me and ask me multiple times. I'm fine with that. But I want the thing should be clear to you. Let's find out gradient. Okay, before jumping to gradient, let's first write this y transpose minus, y minus x beta. This was the equation, y minus x beta in the matrix notation. Let's open it. Let's see what happens. So y transpose minus beta transpose x transpose y minus x beta. Whenever we have to open the transpose in the matrix, it's like, if I'm doing AB transpose, it's like B transpose A transpose. Fine. Now let's open the brackets. Y transpose Y.
Ma'am.
Yes.
Okay, I want to ask the reason of subtracting transpose of beta and transpose of x from y, transpose of y. Then you said y, transpose of y minus beta x transpose. What is the reason of subtracting beta x transpose from y transpose?
I'll come to it. This is the, and now what is this? This is basically the loss function. Loss function means I have something, a target value, which should be the actual value. And I have something, the predicted value. What model has predicted? So I have to find the gap between them. What is the gap? That is basically the loss there. Now, this is basically y, this target. Predicted means I'm predicting it by this x and beta. These are the weights, and this is the feature. I'm predicting it through x beta. Now, what is the gap? That is, which means minus, and I'm doing the squared loss. There are many type of loss function. This is basically the squared loss function which I'm doing. I'm basically doing the square and finding out the difference. And this can be represented in matrix form like this. Now, just I have opened the brackets here.
Okay, thank you.
So now again opening the brackets, multiplying them. So y transpose, yes. Y transpose x beta minus beta transpose y plus beta transpose X transpose X. Just open the brackets. I think there are some queries in the chat. Okay. Okay, what the, oh, sorry. Is my voice very low?
Yes, madam. It is little lower.
Yes, madam.
I'll try to speak it loudly. I have actually done it in full volume. I don't know. P are the number of features, Avanti, and Chavi, in which part you are having the doubt? Can you ask me?
Ma'am, I asked it for that P plus.
Okay. Now is it clear? Now is it clear, Chavi?
Yes, ma'am.
Okay. Sorry, I was not looking at the charts. Now I look at it. Okay. So now I have just opened the brackets, nothing else. Now, one more thing. This is Y transpose X beta. Let's see what happens. Like, what is Y transpose X beta? Let's see the dimensions of this matrix. We know that this Y is basically n cross 1. We have seen this. Now, transpose is 1 cross n. What is this X? Basically, we know that it's n cross p plus 1. We have already seen. And this is p plus 1 cross 1. These are the dimensions which we have already seen. So if I multiply this from left to right, this is basically n cross 1. And 1 cross n multiplied by n cross 1, it's basically 1 cross 1. So basically, it's a scalar. So what is the transpose of the scalar, anyone? If I take the transpose of the scalar,
It will be the same number.
it will be the same number. So can I do the transpose of this? It will, which means that Y transpose X beta is equal to Y transpose X beta transpose. Am I correct? If it's a scalar only.
Yes,
So
ma'am.
this is equal to beta transpose X transpose Y. Here also I have beta transpose X transpose Y. So they both are same.
Yes.
So I can write it as Y transpose Y minus 2 beta transpose X transpose Y minus beta transpose X beta. So now let's take the gradient of it. I was doing this so that we can take the gradient, and I have to find out why we take the gradient. Come on.
Gradient would mean we are differentiating. Differentiating we are doing so that we want to reduce the cost function. We want to reduce the amount of mistakes we make.
Absolutely. Gradient means, if I talk about gradient or differentiation in a real world, in layman language, it means how fast it is changing, the rate of change basically. So I have to minimize, I have to find out what is the minimum value of some, like beta, suppose if I'm differentiating with respect to beta. So what is the minimum value of the beta? Like what is the minimum value of the loss function? What will be the beta there at that point? So let's differentiate it and try to find that. I have done this so that our differentiation part should be easy. Anyone has tried it like by looking at the lectures, or just like professor has told, like, okay, this is this value and you have considered, okay, it's fine. Anyone tried?
Ma'am, gradient will give the minimum or it will give the extreme points?
Extreme. So not minimum. I'll tell you why I was telling minimum. I shouldn't say minimum. Extreme, minimum or maximum. I'll tell you. Let's do this gradient. I'll tell you why I said this minimum. I shouldn't have said before only. So what is the differentiation of this?
0.
0, because there is no beta. Okay, constant. What is the differentiation of this? Anyone?
2x transpose y.
Minus 2x transpose y. How? Because beta transpose with respect to beta, if I say this is equal to I only, 1 only. So that's why it's 2x transpose y. Now, coming to the main part, what is the differentiation of this part? Okay, let's see. Maybe it's tough. Let's see. Let's have this x transpose x. Let's equate this equal to a, some constant.
Ma'am,
And
beta and transpose is same.
now can someone tell me what is the differentiation?
Maybe it's A.
Yes. Can you
Yeah,
speak?
ma'am.
Yes, yes. No,
Yeah,
no.
ma'am.
What? No, no, not a.
It is
So
a
there is,
zero. It is a zero.
no, no, no. There is a formula. Like whenever I have something like this, I should say something like this, the transpose A, B, and some beta, and with respect to beta. So the value is basically, I'll not go in detail. This is basically the formula, you can say. I'm not going how we derived this formula.
Ma'am,
The formula. Yes, yes.
beta and beta transpose are the same thing.
No, 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 no.
Then how we can
But it becomes beta square, right? Beta transpose into beta is beta square, and differentiating a square is 2. That is what is happening right now.
Mm-hmm. Okay, let's take it as a exercise problem. Try to find how we came up with this matrix. How this is equal to this one. This is a formula which is used in matrix notation. If we have the same and this A is basically symmetric in nature, then it is equal to 2A beta. This is a formula. How we came up with this formula? Let's take it an exercise and we'll discuss whosoever.
Ma'am,
Yes, yes, yes.
in the second term where we have differentiate with respect to beta, there we differentiate beta transpose with respect to beta, right? This is equals to 1. Then beta transpose and beta are same thing.
No, no, no. Whenever we transpose, we differentiate with respect to transpose also. It's not the same. It is inverse. When you when you'll check in the internet also, when you will differentiate with respect to transpose, it will be the same only, like I only, identity matrix only.
Okay.
So check this, how we got this 2A beta. This is the formula, how we got this formula. Check this. Okay, should we proceed? Let's take for now, this is the formula. Check this. This is you should do some effort now. This A should be symmetric. And what if A is not symmetric? Then this will not be the result. Like, okay, check this. I'll discuss in the next lecture how we come to this. Okay, for now, take this as formula only. So if this is the formula, this is 0. This is minus 2x transpose y and minus this A is basically x transpose x minus 2 x
మిషన్ లెర్నింగ్ ఎందుకు తీసుకున్నాను
x into beta.
మిషన్ లెర్నింగ్ అనవసరం తీసుకున్నా 2 గ్రేడ్స్ అని తీసుకుంటే ఫుల్
Fine. Fine. Should we
Ma'am, it
proceed?
should be in the last term, it should be plus, ma'am.
Should it be plus? Yes.
Is it plus?
Yes, ma'am.
Minus into minus last 2 terms are minus. So when you multiply it, will become plus.
Okay, okay, okay. Yes, 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 yes. So now 2x transpose y is equal to 2x transpose x beta, which is equal to beta is equal to x transpose x inverse into x transpose y. This was told in the class. Now you got to know how, like, differentiation, maybe only differentiation was missing. Is it fine? How we opened the brackets and solved this differentiation and all? Just
Yes,
with Anyone tried after seeing the lecture? Or you assumed, okay, it will be this answer only. Now, whenever we do the double differentiation, what was the differentiation part? 2x transpose minus 2x transpose y minus x transpose y plus 2x transpose x beta. With respect to beta, this is 0, and with respect to beta, this is equal to 2x transpose x. Is it positive or negative? It's positive. Whenever it's positive, whenever we double differentiate it and the answer is positive, that indicates that the critical point, whatever the beta is, basically that is minimum. Whenever it's negative, I think professor has done some mistake here. He has written minus or something. I hope. Is it somewhere here or another part? So the critical point is minimum here whenever it's positive, and whenever it's negative, it's this means that it's basically maximum. So it's positive, which means that it is basically this critical point is minimum here. Whenever we double differentiate, it tell us that the point which we have find out whether it's for the point is minimum or it's whether it's maximum. Fine. Fine. Should we proceed?
Can you explain the last term?
Just to repeat, positive, then it's a minimum. If it's negative, it's a maximum. Second order differentiation, right?
Yes. So whenever we are double differentiating it, whenever we get a positive number, which means that this is minimum, and whenever we get a negative number, negative this one, if it was minus 2x transpose x, which means that it is maximum. That's what double differentiation indicates. That whatever critical point you find out from your single differentiation, whether it's a minimum or whether it's for maximum. Is it fine? Whosoever was asking the doubt?
Yes, ma'am.
Yes, ma'am.
So any doubts in this linear regression part? Please tell me. Come on.
Ma'am, excellent this derivation, ma'am. So we were not able to understand this thing completely from the videos, but here I think you explained it very well, ma'am, step by step. One request, ma'am, the last point which you mentioned, whether any visualization or something which we can remember. So it is hard to say when it will be minimum and maximum. You said ki it is positive and negative, but any visualization why it is minimum when it is positive, something like that, ma'am, if you can add.
Maybe in the next lecture I can bring up with the graphs and all I can show, or I will maybe I'll add in the drive. Maybe I forgot to add the last notes as well. I'll add in the drive about this minimum and maximum notes. You can check them.
Thank you, ma'am.
So that you can visually see, and if you'll have any doubt, then I can explain those notes as well. Okay, so what we were doing is x transpose here. If I see, this is x transpose y minus x beta only. If I think this is the same only, minus 2x transpose y minus x beta, or I can say x transpose y minus x beta is equal to 0. This is what we have done in one of the step here. So or I can say, usually we write it as y bar. This is the prediction only, what I'm writing. What I'm saying is this is orthogonal projection. How can I say what is orthogonal projection?
The vectors are 90 degrees to each other, but also what it means, if you multiply them by its transpose, it will be -1, which means
A dot B is equal to 0. Why? Because it's 90 degree. Why? Because AB cos theta, this theta is basically 90 degree. So this is equal to 0. So that's why they are basically orthogonal. X transpose E, basically it's equal to 0 here. So that is what they are orthogonal to each other. So what do we have? Why do we have a benefit of orthogonal, or if the columns are orthogonal to each other? Any idea? Okay, we'll proceed. We'll come to this afterwards. First, I'll go with this multivariate regression and then I'll come. This linear regression part with the how we have come with this beta and all, is it clear? I hope so. The things are clear. I have tried to go in detail. Coming to multivariate regression. Was this multivariate regression confusing?
yes.
So, what is univariate before jumping to multivariate? What is univariate regression?
Ma'am, when we only have one feature.
Only when we have one feature of the predictor variable. Absolutely correct. So this x is a single number, suppose without intercept, that is basically the univariate, and beta is equal to this. We have found now only how we get this. Now, as we're talking about, suppose these columns are orthogonal to each other. Orthogonal means x transpose x. If I write, can you tell me how I'll write in the matrix form this x transpose x if they are orthogonal in nature? I suppose this is 3 cross 3 matrix. Can someone help me? Now only we saw that A dot B is equal to 0.
It'll be a identity. Trace, yes, it'll be trace.
Can someone tell me why? Why this is a diagonal matrix? Come on.
Corresponding unit matrix multiplication will be 0. And for 1 place, that will be 1. That's why
A transpose A is equal to I, man.
A transpose A is equal to I. Then why
That is x1 transpose x1 is equal to I.
if I say this is equal to this, does it make sense? Suppose this is P features. Why it's equal to I? I'm getting your point. Like you are saying this is equal to I. Why it's equal to I? Can I say theta is equal to 0? There cos theta is equal to 0, which is equal to 1. You got it? What I have written, or no?
No, ma'am. Didn't get.
What about others? When I'm multiplying with the same one, which means theta is equal to 0, when I'm multiplying with the same one, when I'm multiplying with the other columns, which means they are orthogonal, which means 90 degree, but the same will be equal to theta will be equal to 0 only, because on the same one, I'm saying how much angle, that would be 0 angle only, projecting the same angle to like the same point to same one, that is 0 only.
Yes, yes.
So that's why it's basically cos theta is equal to 1. If I go how these things are happening in back end, like, so which means that equal to square. That's what they were trying to say, that it's equal to I, that is equal to 1. Does it make sense now? And the others are basically orthogonal, which means 90 degree, which means cos 90 is equal to 0, which means that is equal to 0 only. The whole will be equal to 0 only. Does it make sense now? Or it's going above your head?
Diagonals I didn't get, ma'am. Others I got 0.
If you draw 2D graph, it would be easier to show the vectors over there, I guess.
Yeah. Okay. Nothing I'm saying. I'm saying this point is they're orthogonal to each other, A and B. And if they're orthogonal to each other, which means the angle is equal to 90 degrees. And when I'm doing A dot B, which means that AB cos 90, which is equal to 0. This you got it, na?
Yeah.
Or now what I'm saying, A cross A and A only on angle. So what is this angle? 0 degree, no angle. Like this is, they can't do the same point on itself only. That is 0 degree only, no angle. Which means A dot A is equal to AA cos 0. If I'm saying the same point, they can't, A can't be perpendicular to A only. It is basically the angle between them is 0.
Okay.
So which means that equal to 1. Cos 0, 1. So A square.
So A square.
Got the intuition behind this, how I
Got it. Yes, yes.
So that's why this beta is equal to, I can write it as X-ray transpose Y, X-ray transpose X-ray. The same thing. This is the same thing what I have written. X transpose X inverse X transpose Y. And if you'll do this, you'll see this is the same thing only. Maybe I'll show, maybe wait a second, 1 0 and 0 1. Okay, I'll leave to you. Like how we got this, I'll leave up to you. Like this is the same thing. That is what, and this is only possible when I'm using this diagonal matrix. Then we can write in this form. This I leave up to you how we are getting. Whatever points I'm leaving up to you, it doesn't mean that you should go like this the way you have gone in the professor's lectures. Okay, you are thinking, okay, this is equal to this, the differentiation will be equal to this. Don't assume the things. Go and practice it, and whenever you have any doubt, the things which I am also missing, please mail me. I'll reply to your mail. So for the, okay, I hope so you got some intuition about this orthogonal, how we can go to this, how we can write it as in the form of this diagonal matrix. So before jumping to orthogonal, one more thing is there. Now, if I take, I told you like I can write this beta as it is, and I can do this univariate regression whenever they're orthogonal. Not orthogonal means I'll come to this. I'll come to first of all not orthogonal, and then I'll come to more detail. Suppose I have intercept and one variable. What I'm saying, these two are not orthogonal. Not orthogonal means, let's see how. Suppose I have 1 1 1 1 1 transpose X is not equal to 0. That which means it means that they are not or not orthogonal, which means A dot B is not equal to 0. So Nirja, what you are working on? Like you are a student or
Yeah, ma'am. This is my first year of research program PhD from HBTI.
okay,
So, yeah.
first year. Okay, I'll come to you.
Yeah.
I'll come to you. I'm also applying. I'm working on machine learning plus computer networks, both. Like applying
Oh,
them
okay.
on networks, and there I am using this. You'll get to know in coming years, or like I am using this PC as well. Like come to those PCA technique also, like how I'm doing the dimensionality reduction and all, I'll come to you. I'll come to your question, don't worry. You'll apply these more and more papers, you will know how these things. We need to know the maths behind it. Like many of the people have asked me why we need this maths. If you need to know machine learning is nothing but maths only, like how these things are happening actually. You can't say that you are using this model, okay, I'll use this predefined model linear regression directly, and okay, the things are sorted. No, if you want to go higher in industry and all, or in the research,
Yes, ma'am. Actually, I'm confused. मतलब various type of difficulty facing regarding this type of complex derivation. So just asking.
I'll come to answer
Means
after.
okay. There is a need of practice from my side. Yeah.
So one plus 1.1 plus 3 plus 5 plus sorry.
Ma'am, your screen share has been stopped.
Wait a second. Now only it has stopped, or from how long? Have you seen this till this step, or it wasn't visible?
Yes, ma'am, just now it stopped.
Okay. So this is not equal to 0, obviously. So it's not orthogonal. The simple step to check it, A dot B, basically it should be 0. Now, what is the method to do it 0? So let's center it. So how to center it? Calculate the mean. 1 plus 3 plus 5 plus 7 divided by 4, which is equal to 16 divided by 4, which is equal to 4. So x minus x bar. So 1 minus 4 minus 3. 3 minus 4 minus 1. 5 minus 4, 1. 7 minus 4, 3. Now let's try to multiply it. Is it orthogonal? What we have done, can someone tell me? I've just rushed here.
Could you just repeat it, because I definitely missed what you were trying to say.
What about others? Can you see it, and now can you just see for 1 minute? Come on.
You have taken the deviations.
I have taken the mean. I have done the centering. What I have done, I have taken the mean of, when I multiplied with this, it was not equal to 0, which means it is not orthogonal. So what I did, I took the mean of this, which is equal to 4. I have taken the difference between them, the deviation from the mean, exactly. So 1 minus 4, which is equal to minus 3. Sorry, 1 minus 4, which is equal to minus 3. 3 minus 4 minus 1. 5 minus 4, 1. 7 minus 3. Sorry, 7 minus 4, which is equal to 3. And then now when I'm multiplying it, 1 minus 3. 1 multiplied by minus 1, 1 multiplied by 1, 1 multiplied by 3 is equal to 0. I was very fast, I think.
Madam, here you are resuming two vectors. That is the 1111 is the one vector and 1357 is another vector. Yes, madam.
Then are they orthogonal? I'm asking. What I did is A dot B. 1 multiplied by 1, that is 1. 1 multiplied by 3, that is 3. 1 multiplied by 5, that is 5. 1 multiplied by 7, that is 7. When I'm adding them, this is not equal to 0, which means that it is not this is not orthogonal. This is the way I calculate whether it's orthogonal or it's not orthogonal. It's not orthogonal. Now to orthogonalize it, how to do this orthogonal? I'll tell you why we want orthogonal. First of all, how do we do? I calculate the mean of this one, 1357. This is equal to 4. Now I did this x minus x bar. This is basically x. 1 minus 4, which is equal to minus 3. 3 minus 4, which is equal to minus 1, 5 minus 4, which is equal to 1, 7 minus 4, which is equal to 3. Now I again check with ones and with this x minus x bar. When I multiplied it, now it's orthogonal. What I'm doing is, I'm just, whatever the x was when it was not orthogonal, I am basically subtracting it with the main thing. Is it clear?
It is a Gram-Smith process.
Yes.
This is Gram-Smith process, right?
I'll come to that also. Don't worry. Chavi, what you are not getting?
Ma'am, what did we do in this? I mean, what are we trying to find in this?
Okay. What I'm trying to say is, I want that these columns should be orthogonal to each other. Why they have to be orthogonal with each other? Can you tell me? Yes, can someone tell me? I'm doing this orthogonalizing it and doing so.
ए भाई माइनस वन जो है ना लेकिन हई जोड़ी कहियो ना टूटी का
Why I'm doing this? Can someone tell me?
For calculation easier.
What about others? What do you think?
Find the projection.
Okay. So, Chavi, you got till linear regression?
Yes, ma'am.
Anyone else is also having doubt till linear regression? Everything is fine?
Till linear regression, everything is fine, ma'am. Is it because you're trying to take the projection of each and every for multivariate, for example? Is it because you're trying to take the projection of each and every point to the other projection of one vector to another? But that part I don't understand.
I'll come to. Why do you usually orthogonalize? I want to do univariate regression. Univariate means I don't want that each feature should be interfering with the other one. Each feature should have its, like I'll do the regression and simply I should apply this formula and simply I'm done. This formula I can only apply in univariate regression or when they are orthogonal to each other. Orthogonal means these features, they are not interfering with each other. To have these features not interfering with each other, I have to make it orthogonal in nature. How to make it orthogonal? I'm saying take the feature x and just subtract with x bar. Now you'll see that these are orthogonal to each other. This step is also called as centering. By centering, I'm orthogonalize. I'll come to that gram schematics also. Don't worry. This is not actually like just I'm doing the centering. Sometimes by centering only, I'm orthogonalizing it. Only the first feature. Fine now? Or still having doubt?
Yes, ma'am, got it now.
What about others?
Yes, ma'am.
So ask me the doubt like the way she is asking. Ask me in the message chat box so that I can know whether you guys are getting or not. Or I'll take a simple example and I'll explain. As this multivariate regression, it's basically complex. Let's do with the example rather than doing with this. Rather than doing by how by equations and all, let's try to solve this multivariate by the example only. So mu1, what I did is suppose 2, obviously 1, 2, 3, mu2 is equal to 4. So mu1, mu2 means the mean of the first column and the mean of the second column. The step 1 in multivariate regression always is, because I want it that these two columns should be independent of each other. They should be orthogonalized in nature. So I'll start with x and center these columns. So 1 minus 2, that is equal to minus 1, 2 minus 2, 0, 3 minus 2, that is 1. 4 minus 4, that is 0, 3 minus 4, that is minus 1, 5 minus 4, that is 1. So I got my first orthogonal feature as every time this first feature, I'll say it as this is the first orthogonal feature, but this is not equal to Z2. I'll come to it. This is Z1. So I have converted this X1 into Z1. So this X1 is center is equal to Z1. Clear? What I have written this is centered X. Centered X means, centering means subtracting by its mean. Till now clear? Should I proceed?
Yes.
What about others? Should I proceed now?
Yes, ma'am.
What I do, what we want, I'll write it. Then I'll explain. Want to remove from column 2 any part that can be explained by Z1. Can someone explain me what I have written in this English?
What we want is that this first column should be independent of the other one. It should not be dependent on the other one.
Yes. So whatever this is, this x2 will be, it should not include the parts which xz1 is already having. There shouldn't be any dependence between these columns. So whatever, how we do is, we usually do this whenever we are having this, when I calculate this basically using this formula. I have this calculated this beta. Now instead of this, I'm doing, instead of predicting y, usually I predict y, instead of predicting y from x, we are predicting current x column from previous z. So this is the previous z. Now this is the current x column I have to predict. So how? The same way, sorry, rather than gamma, beta, let's take it as gamma. So usually we write here y. So rather than doing that, I'm predicting this x2 column. Here I'm not predicting the y, I'm predicting this x2 column. And I don't want any intersection between them. I can write it as this also. This is the same, just in the inner product form. Inner product is A, B, inner product is same as A transpose B that we have already done. Fine. Fine. Should I proceed?
Ma'am, can you explain this last one?
So what I'm saying is, what we usually do in linear regression, what I have calculated this beta, how we calculate the beta, we usually do like x transpose, what I have written here, you can see x transpose y divided by x transpose x, that is beta. Now this y was the same thing I have written, just I have written here gamma, as what I have to predict y here. So here I am just replacing it. I'm having x here, so z here rather than x, and I have to predict x2. So the same formula beta I have written in the place of gamma, and like output is y, but here the output is x2 and input is z1, where the input is x. You know now how we got this? Come on. Yes. You know how we got this? We have done the differentiation and got this.
Yes. Yeah.
Y was the output. Now what is the output? X2 is the output, because I don't know about x. I want to predict this x2 column basically. Now what was given to you earlier? Earlier x was given to you, so that's why there was x here. Now what is given to you? Z1 is given to you. So just replace this x with z1 and replace this y with x2. Nothing else. And rather than beta, like I have changed the variable which is equal to gamma. Fine.
Okay.
What about others? Okay. Let's proceed. So Z1 transpose. Sorry. This C is basically centered one. Okay. So what is Z1? -1, 0, 1. And what is X2? 0 minus X2 centered. This is 0, -1, 1. So -1. This I'm doing Z1 transpose into X2 column. -1 into 0 plus 0 into -1 plus 1 into 1. Which is equal to 1. And if I'll do the denominator, it's equal to Z1 transpose Z, which is equal to sum of the squares only, which is equal to Z1 is -1, 0, 1. -1 square plus 0 square plus 1 square. We have seen how it is equal to this, which is equal to 2. And 1 by 2, it is equal to 0.5, which is equal to gamma. Now tell me, is it clear?
Ma'am, can you please repeat this once?
Let's see. This is bit confusing. Now I have multivariate regression. What I first main part was, okay, I want to orthogonalize it when they are not orthogonal to each other. Why to orthogonalize it? Because I don't want they should interfere. These features should interfere with each other. I can apply simply the univariate regression. I should apply the simple formula and I'll do it. How to do it? First, what I did, centering. This is basically X centered. How I did the centering? I calculate the mean of the first column, subtracted 1 minus 2, 2 minus 2, 3 minus 2. The same way for the second column. This is X centered. Till this point, clear? Now,
Yes, ma'am.
Whatever the first column is, that is, I'll consider, okay, as it is. That is basically equal to Z1. Okay, that is as it is. Nothing. But whatever is the second column, I want to remove from the second column whatever it is intersecting with the first column, which means I want that they should be independent of each other. There shouldn't be any clash between them. So first, I want to predict the second column. I know how, I calculate this beta. So when I do this univariate regression, I usually do whatever is given to me, X transpose into Y, whatever is the output, and into X transpose X. In this case, I have what is given to me, the first Z1 is given to me. So Z1 transpose. So what is the output I want? Which is equal to the second column, which is X2, second column, and Z1 transpose Z1. That is what I have done and just numerically solved it. Fine?
Yes, ma'am. Thank you.
So now Z2 is equal to, now tell me what I have done. This was just a gamma, the weight factor, whatever I have calculated just like beta. And this is what I was telling about this thing. Can someone tell me what is this? Like what is going on? Come on, come on. Someone was telling gram schematics and everything. Yes, yes, now come on. You have seen the lectures, multivariate regression. Come on. This is week 2. Week 4 are also published. Okay. Can some... yes, sorry.
Is X2 the second column?
Yes, yes.
So what we are trying to do here is gamma is our slope. So we are multiplying gamma with Z1 to see, to calculate the change of X with respect to Y, with every unit. We are trying to minus it with from the another column so that we can get rid of the common point.
Exactly. That is what I have written here. We want to remove from column 2. I want to remove from X2, the column 2, any part that can be explained by Z1. So that's what I'm trying to do. This was the weight factor, which slope factor or weight, which I'm trying to calculate it from here. I'm removing from this second column whatever is clashing with this. So this was like 0, -1, 1. This is, we have calculated 0.5. And this is Z1. Z1 is equal to -1, 0, 1. Yes. This is gram schemats and on like. Now the next step. I know this is confusing. Go through this again and again. You'll get it. Again, if you'll have any doubt, we can discuss in mail. Don't worry. Next step is regress y on Z1 and Z2 separately. Which means I have to calculate this beta 1, which is now simple. The same thing which we have done. Beta 2, that is Z2 and Y. Oh, sorry. I'll write it here. This is how multivariate regression is. Any intuition you got, or is it going above your head? Okay. Yes or no? Say something. Is it going above your head?
No, ma'am, we are getting it.
What about others?
Clear, ma'am.
So what is done? Like we are finding it, like we are first centering it for orthogonalization. Then we are saying, okay, Z1, keep unique information from X1. Okay, just basically do the centering thing. Z2, keep what is new in X2 and remove what is overlapping with X1. Simple. For that, we have done this, and then we have applied the simple thing. The same what we have done. This is what? Keep unique information, whatever information is in X2, and then remove it, whatever it is overlapping with X1. That is what I'm trying to do. I hope so. This is clear to you. Again, if you have any doubt, mail me. Maybe I'll give the notes or I'll explain you in more detail. That's what I can do.
Just one thing, that minus 0.5, that is beta, right? 0.5 minus 1, 0.5 is beta.
5 minus 1.5. Where?
The right at the end, after you got the new, after x minus gamma Z1.
Okay, this one. This is Z2. This is like what I'm trying to do is this X I'm converting it to Z1, Z2. Basically,
Okay, and
orthogonal.
Z is the same.
The voice is
Z2 is
independent. Gaurav, I can't hear you. Your voice is cutting. Again, can you speak?
Okay, but please continue.
Is it clear? What I'm doing is Z1 is the same.
But please continue, but please.
Is it clear to you, or you are having any doubt? I don't want, like, I should proceed and the thing should be like this only. So what I've done, simply I'll just quick recap. Just taken the X1, centered it, and that's equal to Z1. Changed the feature. Okay. Just for X2, what I have done, I have not talking about the maths, just talking about the normal intuition. What I have done, I have basically taken like what is the overlap between, I want this new X2, or I will say the Z2 thing, but I don't want that it should overlap with the previous Z1 or the X1 thing. So that's why I have basically removed this overlapping feature by calculating this gamma the same way we usually calculate this beta, and then the same univariate regression I have done. Okay, let's proceed. I hope so. Some understanding you have got. If not, please mail me. we'll discuss more about this. Now coming to the next thing, that is subset selection. If you want more examples or anything, maybe I'll post it in Drive by explaining these things. So why we do subset selection? Any idea? Come on. Come on, fast.
Okay. We use subset selection when we have a large data set. So we take a subset which is relevant.
Yes, exactly. We want to take the subset which is more relevant, so that yes, exactly. So if suppose I have 135 parameters, I want to know which 4, which 5 are important to me. So that's why I'm doing this subset selection. And moreover, it do reduce variance as well. How it is reducing variance? What is the role of variance? You remember the last lecture, bias and variance? Remember? Okay, I'll come to the other one. Remember?
Yes, ma'am.
How it is reducing variance by doing the subset selection? Where the variance is low. If I talk about model complexity,
The variance is low when both the curves are near to each other.
okay. If I talk about model complexity,
as the model starts to get more complex, it starts to have more variance.
So if the if I'll say if there are lesser parameters, if the model is less complex, can I say the variance is reduced? We have done now that if the model complexity is less, which means there are lesser number of parameters, the variance is reduced.
Yes, ma'am.
That's what I'm trying to say. This symbol means Chavi in a product, which is equal to, like, if I say A, B in a product, which is equal to A transpose B. Got it? So, reduce variance. Okay, if I'm doing this linear regression, least square fit linear regression, what I try to find it, like, okay, I want that the bias should be very less. There should be zero bias. I mean to say that the predicted value should be equal to the targeted value. That is, the bias should be less. But doing the bias less, what happens? Sometimes by increasing the number of parameters, making the model more complex, as we have seen, the variance is high. So that's why I want that variance to be reduced. The variance should be reduced. We can do it by subset selection. The second is interpretability. Can someone tell me what is interpretability? Yes, come on.
From this, I think how X.
Biplav, I'll come to dimensionality reduction. I'll come to that concept. Just interpretability, the way I think one of you, I forgot the name, Foster, he has explained. Basically, it should be for human understanding. It should be easier if we are the number of parameters. Like if I talk about 130 parameters, and if I say which 4 are important to me, for that interpretability for human, so that human can understand what is the reasoning, which parameters are basically more important. I should get to know rather than going through these. I can get to know which are basically more important. So that is basically, I want to know which parameters are more important, and on the other hand, I want to reduce the variance as well. So for the best subset selection, we have many techniques like forward, stepwise selection, backward, stepwise selection, hybrid one. So can someone tell me like what is this forward stepwise, what is this backward stepwise, and what is this hybrid one?
I'm sorry, ma'am, but can you please repeat what were you telling about interpretability?
Interpretability is nothing, just it's like uh like which parameters if I talk about the layman language, simple words, interpretability means human can like understand the reasoning behind a model decision or something. But if I talk about in this particular subset selection, it's like which model features are more important to me. If I'm having many features, like 300 features, I want to know which features are more important to me inside it, rather than like okay explaining like 130 are important. It's like which are more important for the human understanding. Interpretability is like human can understand the reason behind which features are more important in this subset, in this basically whole model, nothing else.
Is like we see the relation between x and y, and then we try to interpret that which feature is best suited with y.
I want actually it's like I don't want why we are doing subset selection. I don't want to use these many of the features. I want to know which features are more important. Maybe it can be like okay, I'll include only 4 features in my the model. I don't want to include the other one. So which are more important? That is basically helping me in subset selection.
Okay, ma'am. Thank you.
Okay. Now, can someone tell me about forward stepwise selection, backward stepwise selection?
So forward stepwise selection would be that you keep adding each and every parameter one by one to check whether the total function is explaining why. The output input that you're putting is explaining why.
Can you repeat? Can you repeat?
Ma'am, if y is equal to beta naught plus beta one plus x1, x2, x3, you'll keep adding x1, x2, x3 as long as it explains why. That's forward stepwise. And backward would be you put the entire x1, x2, x3 and you keep reducing the parameters until it explains why better.
Yes, exactly, exactly. So forward stepwise is, as he said, okay, let's start with one. Let's start with the suppose intercept only. Now I'll keep on adding one new variable. Suppose I'll keep on adding, like suppose x1 I add, the next two I'll keep on adding one new variable which will give me the best performance. So I'll keep doing this until my residual drops out, until my loss function is very less beyond some threshold. Like it's like okay, this till this point I'll keep on adding the features. Backward stepwise means I'm taking whole features, I'm taking whole of them, and I'm keep on dropping them. Is it correct? Is it correct?
Yes, ma'am.
And what is about hybrid? Can you think like what can be hybrid? It's like
You
growing.
will add and subtract.
Yes, yes. So what I'm doing is I'm growing up to certain level, and then maybe dropping the features can give me better solution at some point. So it's like both adding and subtracting. When to like sometimes adding and then I'm thinking, okay, I can drop and I'll still get the good result. So it's good to drop now. So it's like taking both of them. Now, what is stage wise? Am I is it stage wise or stage wise? What is stage wise selection? Am I getting confused? Is it stage wise or okay? Let's see. Yes.
It's stage wise.
Stage wise. The next was stage wise. Yes, yes. I was confused between step and stage. Yes. Now, what is stage wise? Okay. Can you hold a minute? I'll have water. Just 2 minutes. Give me 2 minutes. You can also take rest. Just 2 minutes. Yes, what stage-wise? Any idea? Am I audible?
We can hear
Yes,
you.
ma'am.
Yes.
What stage-wise? Okay. What stage-wise? Yes, come on.
It is a regression method where we add and remove the predictor variable while modeling while doing the regression model.
What about others? Okay. Let's see otherwise. Was it complex? Okay. Those were simple. What was done? Just adding the features, just removing the features.
Yes.
Now let's see about this. How the things are there.
Stage-wise is complex, so that's why I'm waiting for you.
Let's see. Yes, it's complex. So the step one, what they do is, so pick the variable that is most correlated with the output. What do you mean by pick the variable? Okay, let's take the example and try to solve this stage-wise so that the thing should be clear to you. Let's see. Suppose I have y output as 10, 20, 30, and x1 as 1, 2, 3, x2 as 2, 4, 5, x3 as 1, 1, 4. So pick the variable that is step one is that is most correlated with the output. So how can you find, anyone knows? How can you find like what is the step one? Which one is most correlated? How will you find, any idea? Okay, let's see. Let's see the step one. I'll tell you what is the correlation. I want to find which is most correlated with the output. So we have the formula of correlation. So this is the formula of correlation, which means x minus x bar, y minus y bar. Let's solve it so that it should be clear to you. If I talk about y bar, what is y bar? Which is the mean 10, 20, 30. What is y bar? Come on, what is y bar? 20. What is x1 bar? Are these examples helping you? Am I audible?
Yeah.
Yes, ma'am. Yes, ma'am.
So x1 bar is this. Okay. So what I'm doing is, let's do for x1 first this one and find out the correlation with the output. I did x1 bar, I did y bar, then x minus x bar, which means 1 minus 2, 2 minus 2, and 3 minus 2. This is 3. So x minus x1 bar, x1 minus x1 bar. 1 minus 2, 2 minus 2, and 3 minus 2, which is equal to minus 1, 0, 1. Y minus y bar, which is equal to, okay, 10 minus 20, 20 minus 20, and 30 minus 20. Minus 10, 0, and 10. And x minus x bar multiplied by y minus y bar, which is equal to minus 1 into minus 10, which is equal to 10, 0, and 10. Sum of them, which is equal to 20. X minus x bar square for this one, x minus x bar square. X, okay, the same thing, just square of them. Minus 1 square, 0 square, and 1 square, which is equal to 1, 0, 1. Y minus y bar square, which is equal to 10 minus 20 square, which is minus 10 square, which is equal to 100, 0, 100. Sum of them, sum of this is equal to 2. Sum of this is equal to 200. 20 divided by square root of 2 into 200. 400, which is equal to 20, which is equal to 1. Got it? How we are finding the correlation? Just maths using this formula. I should have rushed here actually. Done nothing. Actually, I should have rushed here. Just I have found that okay, what is the correlation of x1 with the y output. Similarly, I'll not solve now. What is the correlation of x2, which is 2, 4, 5 with 10, 20, 30? Suppose the correlation is 0.89. Similarly, what is the correlation of x3, which is equal to 114 with the output 10, 20, 30, which is equal to suppose 0.76. Done. So done with the first step. Pick variable that is most correlated with output. So which one is most correlated with the output?
The first one, x1.
X1. So I picked up x1. Step 2. Regress x1 with output. Simple regression. Y is equal to beta 1 x1. What is beta 1? Similarly, x1 transpose y into x1 transpose x, the same thing. The same thing. I have written. What is beta 1? Now x1 into y. What is x1? I'll write here. This x1 is equal to 1, 2, 3. What is y? That is 10, 20, 30. I'll write here so that it should be convenient. 1 into 10 plus 2 into 20 plus 3 into 30 over 1 square plus 2 square plus 3 square. 60, 64. 1 plus 9, 13, 14. So suppose it's 10. It's 10. Okay. We got the beta 1. Clear till now? Step 3. Make prediction and find the residual. I'll come again to the steps, don't worry. How to make prediction? Y is equal to beta x1. You know, beta 1 x. Beta 1 is equal to 10. X1, 1, 1, 2, 3. So 10 into 20, that is 20. And 10 into 3, that is 30. So residual, 10 minus 10, 0. 20 minus 20, 0. 30 minus 30, 0. First of all, tell me, are these things clear? Then I'll proceed.
Ma'am, in y cap, why are we multiplying x with y?
X with beta 1, beta 1.
Yeah, beta 1.
What is linear regression thing? How we are doing?
Got it.
We are doing this now. I'm not taking any intercept. I'm calculating what is y basically. And then this is basically residual. What is the predicted minus actual? What about others? Should I go again? Like just a quick recap. Should I do again? Come on. Fast.
Yes, ma'am.
Okay. So, what I have done, as I told you in the Stagewise, what I'll do, simple, pick the variable that is most correlated with the output. This was just a correlation formula. I find out that x1 is most correlated with the y by the formulas and all. Okay. So I find out x1 is more correlated. What is the step 2? Regress x1 with output, which means do the regression. And for that, I know what is beta. I need not calculate it. I know the formula here. I just applied the formula here for the beta and just did the regression and find out the y here. And then when I find out the y here, then I calculate the residuals. Residuals means what was the actual y and what was the predicted. Still any doubt? First of all, find out which variable is most correlated. Then do the regression part. Simple, how to do the regression? Beta 1, we know the formula, y is equal to beta 1 x1. And then find out what is the residual, what is the actual difference with the predicted one. Done? Come on.
Yes, ma'am.
What about others?
Yes, ma'am.
Now, the step 4. Though it's 0, it shouldn't be 0. It's the very ideal case. Suppose it's not 0. Don't take, it was an example. So now find the next variable. This is what we are doing. Okay, this was important one. This is most correlated with the output. Now, what is the next step?
And the next one with the higher correlation is what you're saying. So it was 0.76.
X1 is
No,
having
0.89.
X1 is having the highest correlation. X1 is
X2 is 0.88. So that's what you're saying, ma'am.
X1 is correlated, most correlated.
So 0.89.
I'm not getting your question. There is some disturbance from your side. Anyone can explain what he's saying, or you can unmute yourself again. Come on.
He was saying next you have to take x2.
No. It's not necessary. I have to take x2. I have to find out which should be the next variable. If suppose x3 the correlation was 1 and it was 0.76, then I should have chosen x3 rather than x1. So it was just because of the numerical form, not just because of the results. It was not that take 0.9. No. Correlation. No. Now it's not like I'll go to this. I'll tell you the next. Now, what I have to do, now I don't have to see this. Just I have to take the first one, which is having the highest correlation. How to find out the next variable? Which one should I pick? It should be find the next variable. How? Pick the variable that is most correlated with residual. Come on, now can someone tell me what I'm doing? Why I'm doing? Why with the residual? Earlier, what I did, first step, I picked the variable that is most correlated with the output. Then I did the regression. I found out the residual. Then what I'm doing, I'm not doing now with the output. Okay, that is done. Now I'm doing pick the variable which is correlated with the residual. Though it's like it's 0. Though in the ideal case, like this is the ideal case. No, though in practical case, in real case, it will not be 0. So I'll have correlation with these residuals. Then I have to find out which is correlated, which variable is most correlated with the residual. But why I'm doing with the residual? Anyone? Come on. Come on, come on. Yes, yes.
Maybe because that is the gap we want to fill.
Getting the idea. What about others? So what I have to do, like I did with pick most correlated, pick the variable which is most correlated with the output. That was the strongest predictor I could have find out. Now I am finding out the variable that is most correlated with the residual. Why? Because whatever the error is, residual is what is the error? I'm fixing the remaining errors. Or in other words, I can say I'm fixing the mistake from step 1. So that's why I am finding out what is correlated with the residual. Now suppose x3 or x2 is supposed the most correlated with the residual. Now you know now how to calculate the correlated one. You know I shouldn't do now because it will take a lot of time. Now you know how x2 or x3 suppose it is most correlated. And now again you'll find out suppose x2, then you'll again find out beta 2. Now y bar, what will be y bar? It was like before beta 1 x1. Now what will be?
Beta 2 x2.
No. It will be beta 1 x1 plus beta 2 x2. Because first one is there now. First one is there. Now what I'm doing? Subset selection means which variables to include. Earlier, only one variable I was including. That is x1 because x1 was most correlated. I know x1 is already there. I have to include this x2. Got it?
Yes,
what about others? Only
Yes,
3-4 students are participating. Yes. If you have got the concept, please raise your hand or write in the chat understood so that I should know and proceed. If you haven't, please.
Here I wasn't able to understand. So first step, it's clear how we have identified the first variable. To identify second variable, you mentioned that it should be correlated with residual. So how to identify that which variable is now correlated with the residual?
Okay. Like this was the y output. I find it out this the same correlation. The same way, suppose residual here it was 0, but in actual case it is not 0. Suppose it's like 1, 2, 3. The same way, the other variables, this is gone out. The other variables, like obviously there will not be three variables. There will be a lot of others. I'll find out the correlation with them. Again, I'll find out which of them will give me the highest value. This is suppose the residual. Then again, I'll find out which one will give me the residual. So instead of doing with this y, I'm doing just with this residual, the same formula. Instead of this y, this is our residual thing. Got it? Sachin?
Yes, ma'am. Yes, thank you.
I'll repeat on. Till I'll get to know, okay, the residual is very less. Though we got here only 0. So, yes.
So what you're doing here is after finding the correlation with the residual, the beta 2, and then in y hat we are adding the beta 1 x1 and beta 2 x2 so that the first one
I'll get it. Now we have earlier why were we were doing beta 1 x1 because I was having like suppose I have p features like here I have beta 1 x1 plus beta 2 x2 n beta n xn. We usually do like this a linear regression. But now what I'm saying is this is forward stage wise. What I'm saying is first include like suppose it can be 3 also x3 also. Like first include those which are having first include only that one which is having highest correlation. So x1 was having highest correlation. So I did linear regression, y is equal to beta 1 x1. Then I again correlated with the residuals. Then I find out which one is having. Then when I'll do this linear regression, obviously I'll include this one also. It's not like only x2 or only that one only. I have to include linear regression means I have to include the others as well. Na? So now I have two variables rather than one. Got it?
Yes, ma'am. And then after this, when we find the residual, it should come as 0. I mean, it should be minimum.
Minimum, yes. Some threshold we'll set up or something like that.
Okay, ma'am. Got it.
Coming to shrinkage methods. I'll not go, okay. Maybe you can go through the stepwise and stage-wise difference. Like anyone can tell me which is converging faster or which one not? Forward stage-wise or forward stepwise?
I think stage wise.
Why?
It first determines the most relevant variable, and then it subsequently adds further relevant variables. So it can make prediction more prediction will be closer to the actual value.
Exactly. I hope this these methods, this subset selection, is it clear to you? Should we move ahead for the shrinkage methods? Should we move ahead?
Yes.
Can someone tell me about shrinkage methods? These are very important. How many types, or can you tell me? Okay. I have ridge regression and lasso regression. I'll first go with the very basic concepts. Then I'll go in detail with the mathematics. So usually they're not heuristic, as they are the same like subset selection, but not that much heuristic. They are some using some coming up with some optimization problem. They sometimes we are setting up the coordinates as 0 as well, or sometimes very low, basically shrinking up the coordinates. Why we are doing so? Let's try to understand. In other words, we also say regularization. Like suppose I have so what I'm doing is, like suppose let's talk about ridge regression or regularization. What I'm doing is, in simple words here, shrinking up. Shrinking up means, suppose this is the same only, I'll not touch intercept here, and it's like 0.7 x1 plus here suppose 2x2 plus 5x. So what I'm doing is I'm shrinking up these coefficients. That's what I'm doing. And which one is the most important coefficient? We know that is the x3 one. Why we are doing? Obviously, can I say reduce model complexity, reducing the variance? And if I talk about, in other words, it's computationally also like it's very expensive. How we are doing? In simple words, I'm saying simple language. What I'm doing, this is a loss function. I'm adding some penalty. So this penalty in ridge regression is this, which means L2 norm. I'll come, this W, it's nothing, just a variable. I'll come to this.
Excuse me, ma'am.
Yes.
And how does reducing the weights help us lower the complexity of the model?
Can someone tell?
Does the lowering of the weight mean that we are removing the variable out of
the whole process?
No, lowering doesn't mean if I'm doing 0x1, it do mean that I am removing this variable. If I'm doing 0.1, which means there is x1, but its weight, it's actually it's lesser complex, I can say, because it's having lesser weight. I'm not giving much emphasis on that. If I talk about this 40x3, which means the variable is very the coefficient, the weight given to that variable is very high, which means it's computationally also, if I have to do calculation also, then also it's very complex. The model itself is very complex. You can think in that way.
Okay, ma'am.
Okay. Maybe. Okay, I'll come to the I was thinking to show you diagrammatically. Okay, let's show. Okay, suppose I have alpha, which means the coefficient. This is suppose the alpha part. This is like this. When I'm increasing this alpha, this alpha is this, not this is the penalty which is added, which means I'm reducing this. They're not removed. The highest coefficient here was this, the highest here is this. This penalty is added. That's why this is basically reduced. The value of, by increasing this alpha, by increasing this penalty, I'm reducing the coefficient size. Okay, let's try to understand it more. By mathematics. Can someone explain me this first? Come on, come on.
Why is the output beta naught is the intercept, and then minus that is you're trying to reduce.
Can I say simply, I have this regression formula I have just written that I want to find out the minimum beta by just rearrange that, like the loss function, or like what is the minimum beta here, rearranging of this, the squared loss function. Can I say? Is it fine or not? Is it fine? The same thing I have written. What is the squared loss function? Not squared loss, like what is the basically minimum beta I have to find out with this, the same thing. Come on, is it fine?
Is it that we are subtracting the predicted output from the actual one?
Yes, 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 yes. Now what I'm doing is I'm adding the penalty term, the same alpha term or lambda. I should take the same variable. I should, as the professor has taken, so that you shouldn't get confused. This is the penalty term. Whenever I'll increase this lambda term, these coefficients actually decrease. I want this beta to be small. Why I want to reduce the variance. I want the model complexity to be less. Is it fine? I want the coefficient shouldn't be high. Model shouldn't be that complex.
Ma'am,
Yes, yes.
Why are we adding the penalty in this?
Why we are adding the penalty? It's like in ridge regression, we usually do to reduce the coefficients. The coefficient we use to add this penalty. By adding this penalty, the coefficient size is reduced. Maybe let's take it as an assignment how it's reduced. Like I'll give you in drive. I'll add that example. Maybe try that, like how it is going to reduce. If you'll not get, I'll explain in the next lecture. Till now, like by adding this, try to understand that by adding this penalty term, this coefficient size is basically reduced. Now,
Ma'am,
yes, yes.
ma'am, can you tell me the range of lambda?
What do you think? What can be the range of lambda?
It should be less than 1, I think, 0 point something.
Exactly. 0 to 1.
Ma'am, also is the value of penalty in minus?
It's square, na? So it will be obviously in plus only.
But why are we adding a penalty in the first place? We are reducing. So this summation of xi bi we are doing so that we can reduce the coefficient of every single parameter. Then why are we adding a penalty?
By adding the penalty, that's what I'm saying. Let's take it as an assignment problem. How by adding the penalty coefficient sizes? Can someone tell me, or you can think about this?
It is basically to compensate. I mean, we have first uh, reduced the reduce the coefficient or weight of the coefficient, and to reduce, uh, since we have reduced it, there must be some penalty. So this is compensation of the penalty.
Yes, yes, yes. You can exactly, like this is compensation of that loss. Like by adding this penalty, we are reducing it. Maybe you can. Maybe I can come up with the example to show that how by adding this penalty, like this is nothing. This is the loss function. Like what I'm doing is here y minus yi square. This is the loss function. This is the loss. Sorry, this is target. This is predicted. Just I'm adding this penalty term. Now you all are asking how this penalty, when I'm saying that I'm taking the large lambda, I'm actually reducing. Just take an example and try to solve like how by taking this penalty. I leave it up to you. Like how by taking this penalty actually this coefficients are basically decreasing. If you'll still not get it, or we'll discuss in the next lecture. I'll come up with an example so that you can understand. Like how by taking the penalty term, this is actually, these coefficients are actually reduced. Now here I'm taking L2 norm. Can someone tell me what is L2 norm?
Ma'am, can you please repeat the question?
Can someone tell me what is L2 norm?
L2 norm is ridge regression because you're taking a square over here.
Yes, yes, yes. L2 norm is basically, what is norm? Professor has said in many lectures, norm.
Magnitude it is.
Magnitude, length basically. So L2 norm means taking the sum of the, this is basically L2 norm. I'm doing the sum of the squares. That is basically L2 norm. So what is L1 norm?
But just adding.
Sum of the modulus absolute values.
Just if I take this is L1 norm. Is it fine? When I'm doing the ridge regression, I'm taking the L2 norm. When I'm doing the lasso regression, I'll do the L1 norm. So this is basically L2. Fine. Should I proceed?
Yes, ma'am.
I know I can write like this. The squared loss function, the residual sum of the squares. But here, this is added. And I can write the sum of the squares like this. Fine.
Yes, ma'am.
Now again, I'll find out what is beta here in the ridge regression form. Let's try to open the brackets. Y transpose minus beta transpose X transpose. Into Y minus X beta plus lambda beta transpose. Y transpose Y minus Y transpose X beta plus wait a second, Y transpose Y minus, okay, sorry, minus beta transpose X transpose Y plus beta transpose X transpose X beta. Fine.
Yes, ma'am.
Same way, if you'll do that, okay, this is the scalar and this is the transpose, the same way, Y transpose Y minus, okay, this will be added. The same way, if you'll do Y transpose Y minus, I can write it as, because it's a scalar, as we have done before also, I can write it like this. You got this step, or I should repeat?
Got it, ma'am.
What about others?
Got it, ma'am.
Now, Y transpose Y minus 2 beta transpose X transpose Y. Let's take it as beta transpose as common. X transpose X plus lambda I into beta. Just brackets. Fine. Derivate, let's again do the derivation because I want to find out the beta. With respect to beta, let's derivate it. This will be equal to 0. What about this? Minus 2x transpose Y. Fine. What about this? Can someone tell me? Come on now. Now only we have done.
Plus 2 beta.
Plus 2.
X transpose X.
X plus lambda I into beta.
2AB. Like beta transpose A beta. If I'll derivate with beta is equal to 2AB. 2A beta. Find the same formula. This was taken as A, suppose.
Yes,
So similarly, minus X transpose Y. I can remove this 2. It will go that side. You got how we got this beta here in the ridge regression. This is beta ridge. Fine.
Yes, ma'am.
Should we proceed? This is basically ridge regression. When we are adding, the simple thing is when we are adding this norm, this penalty terms, we are basically trying to reduce the size of the coefficients. How? Let's take it as a task. How? But we are here using the L2 norm here. How we are shrinking all the betas towards 0. That's a task. Like how these all betas basically, this is shrink to 0. And one more thing I forgot, sorry. We are basically not here using this beta not here. I'm so sorry, I forgot. Beta not, I'm ignoring it in ridge regression. How? Basically, I'm doing the centering. And just this one more task. How by centering beta naught is basically ignored, or which is removed, or it is equal to 0. Let's take it as a task like why is it? Please do remember these in the next lecture, because I usually forgot whatever I have given. In the next lecture, have a make me remind these things, like why we are basically. I have asked you these questions. Is it fine? Should we proceed?
Yes, ma'am.
All your voices are very low. Please have
Yes,
some.
ma'am.
Is it very like?
Yes, ma'am.
Now talking about lasso regression. As I have already mentioned that lasso regression, what we are doing is we are basically in lasso regression using the L1 norm. L1 norm is basically just the magnitude, not squaring it up. Simple. Now, what is the difference between them? Or we usually say L2, L1 regularization we are doing, there we are doing L2 regularization. So, why we are doing, what is the difference between them? Can someone tell me in Lasso and Rich? Professor has actually explained very well this concept. Is someone?
But the beta will not be square. It will the with the penalty it will not be beta square. It will be beta absolute. Yes.
This is absolute. So this is L1 regularization. Actually, I'll show you the diagram and tell me what was the difference. Why I did was there was a purpose of doing this. This is shrinkage. This is ridge regression. Maybe I'll draw it here only for the comparison. This is ridge regression. If I do lasso regression, now tell me the difference. Sorry. What is happening? Can someone tell me? Come on, what is the difference between lasso and ridge? I've tried to visually, maybe it's not correct. Some intuition.
Variance is high, ma'am.
Huh? Yes, you were correct.
The variance is high.
No. Actually, as you can see, there were 1, 2, oh, sorry. This is 1, 2, 3, 4, 5, 6. Here only 4 are there. These variables. Because others are basically shifted to 0. You were asking me na, that actually, ma'am, there are 0 only. I told you no, in ridge regression, they are not 0. But in lasso, there is a possibility of missing these variables. Like this will be converted to 0. Why this will be converted? Why here? By changing the norm. Can anyone explain me?
Maybe because we see if a feature is important or not.
So it's like feature selection. Why? Like by changing the norm only. What I have done, I haven't done anything. I have only, instead of using L2 norm, I'm using L1 norm. How? By changing L2 by L1, I'm doing feature selection here. I'm converting to 0 here. And there, I'm shrinking it up. Actually, they're not 0. Why?
Do we get negative over here in this case?
No. It's not. Okay. It can. No, it's not about negative. It's 0 only. Absolute. Absolute means no negative.
Maybe because in this some due to penalty, some of the features get almost 0, so they get cancelled.
But why? Here only I'm using L1 and L2. You are correct. Yes, that here it's 0. Why it's 0 here and not there? More probability of getting zeros here and not there.
Maybe because if you take a square, then if it's like 2 square, that will become 4. But so 4 into, if you take the penalty as 0.01, it will be 0.04. But if it is 0.01 into just 2 absolute, it will become half of that.
Can you repeat? Can you repeat the numbers again?
So imagine if beta j is actually 2.
Wait a second.
Sure.
Okay, let's proceed.
Ma'am, I'm saying let's say the penalty is 0.01 and beta j is 2. Now beta j square would be 4 and beta j absolute will be 2. So if you multiply it with the penalty, it will reduce to almost nothing. It will be insignificant. Is that what you're trying to say?
Yes, somewhat. Like suppose I am reducing 1000. This is the same example the professor has also given to 9999. So if I'm doing the lambda L1 regularization, which means lasso regularization. So here the lambda into 1. In L2 regularization, it is equal to 1000 square minus 999 square. So it's like lambda into 199, something like that. The same thing. If I'm doing 1 to 0, this is also equal to lambda into 1 gap. In L2, it's like equal to 1 square minus 0 square, lambda into 1. So L2 will choose the higher penalty. Which one it will choose? I'm reducing the coefficient from 1000 to 9999. In L1, it's like subtracting the absolute values, just subtracting the 1000 with 999. Here, it's like subtracting the squares of the values. Are you getting my point? Come on. What I have written? Yes.
Regularization, the difference of the squared values, it will be higher. So that is why the features will not get cancelled. But in L1 regularization, because it is not squared, so we'll get the
I'll come.
The difference of both, it will be lesser.
Yeah, somewhat. So what it is doing is L1 regularization. It is treating all the coefficient reduction equal. For it, 1000 to 999, reducing the coefficient from 1000 to 999 is equal to reducing the coefficient from 1 to 0. But in L2 regularization, reducing the L1 1000 to 999 is giving me much higher penalty. It's much good than reducing from 1 to 0. Where penalty is high? Obviously in this one. So L2 regularization will choose this one because it's giving me higher penalty. Okay, I should choose this one. This will give me more benefit. But here, it is treating both of them equal. Yes, Ekshit, I'll help you. Don't worry. 1 minute. You got the concept?
No, ma'am.
Yes.
Are you
Anyone?
trying to say that it is?
One minute. I'm getting the calls. 1 minute. I'm so sorry. I'm so sorry. Let's start.
You try to say that because of the square, it will penalize the larger value more than the smaller value, but because it's because of without taking the square, it will penalize both the larger and the smaller value equally.
So, yes.
You
Exactly, you are correct.
that in the second case, L2 regularization will have higher penalty, and you said that because of penalty, our beta will be reduced. How is it that in L1 regularization, our features are getting almost cancelled, but in L2 regularization, it is not, even after our penalty is higher?
What I'm trying to say, if I have a chance to reduce from 1000 to 999 and the other chances to reduce from 1 to 0, L2 regularization will choose this one, 1000 to 199, rather than choosing from 1 to 0. Why it will choose from this one? Because it is giving more penalty. It will think, okay, this is giving more penalty, so I have to choose the coefficient from 1000 to 999. I have to reduce this coefficient. Whereas L1 will treat both of them equally. Because what it will think, okay, they both are giving me equal penalty, they both are giving equal shrinkage, so I will choose them both equally. So it has the more chance to reduce to 0. But here, as I have any number, it will like 99 and 98 here, 1 and 0 here. I will choose this one because it will be the square and it will give me higher penalty, and higher penalty means I'll choose this one. I'll do the shrinkage of this one. These coefficients will give me higher penalty. Getting my point?
Yes, ma'am.
What about others? So that's why L1 regularization is more to feature selection. Okay. First of all, please, everyone is able to understand, or only 3-4 people are understanding?
I'm not able to get your point, ma'am.
Okay. Other lecture, whatever I have told you, are you able to understand? Only this one, as I'm getting some messages that people are not able to understand the concepts. Is it like that? Like,
Ma'am, I got all the concepts whichever you taught in the previous lectures also, and this lecture also.
What about others? I don't want, okay. Only 3-4 should understand, as I'm getting this message. Everyone
We
is
understood, ma'am.
We actually need a little more time to explain these. That's
I can't, I'm giving I can't you obviously it's from your end also, it should be two-way process. Ekshit, I'll help you as much as possible. You can mail me or you can stop me. I'm again and again asking you. Wherever you are not getting like this concept also, I'm explaining it 10 times. So ask me wherever you are not getting. It's not like if you are understanding, then it's fine. Otherwise, stop me there only. Okay. I'll come. Suppose I have to penalize. Let's start. Whichever whichever penalty is more, that will benefit me. That will give me higher shrinkage. Fine. According to this regression rule. L2 regression, I did 1000 and 299. These are the coefficients. And this 1 to 0. Which is giving me higher shrinkage, which is giving me more like if I'm shrinking from 1000 to 999 and I'm shrinking to 1 to 0, which is giving me higher penalty in L2 regularization?
The above one.
Above. So whatever the coefficients will be, I'll choose this one rather than choosing this 0. I'll choose this one. I'll choose this shrinkage. What about an L1 regularization? I'm treating both of the coefficients as equal because both of are having the gap 1. I'm not squaring it up. So that's why there is a chance of getting 0 in this L1 regularization. Whereas whenever I'll do this L2 regularization, there will be square and 1 to 0 will always be less. So the chance to get the 0 is lesser in L2 regularization. Maybe we can discuss more in the next lecture. Is it fine?
Ma'am, the 1000 and 199 are betas.
Coefficients, yes, betas.
Betas. We need to reduce 1000 to 999.
Yes.
Okay.
So what I'll do, whatever the gap, I'll square it up in L2 regularization. Where the gap is more, I'll see, okay, this will give me higher penalty. So reducing this will give me more benefit, more penalty, rather than 1 to 0, 1 coefficient to 0. Yes, penalties help in reducing the weight, Shavi. Maybe we'll continue with this. Any doubt in the previous part? I don't want like only 2-3 students should understand, or Ekshit, where you are having the doubt, you can ask me. What about others? Whosoever is attending the lecture?
But derivations are difficult to understand. Concepts can be understood. Derivations are little tough to understand.
So derivations, what we have done in derivations today, just it was the differentiation and just the formulas only of the matrix one. So go through it like once or twice. Obviously, by one go, for everyone it's difficult. Go through it twice or thrice, you'll get to know. And if still you are not able to understand, you can mail me.
Okay, yes, ma'am. Yeah. Is there any, I mean, all these derivations, is there any consolidated, are there consolidated notes or?
These notes, maybe I'll share it in Drive.
Okay, ma'am. Yeah.
Maybe we'll continue. I thought that, okay, we'll complete. Now I think Lasso and Ridge also, I think so you get the intention behind this. We'll continue with the partial least square PCR. That will not take much time. That is just like multivariate, this PCR basically. And this partial least square and PCR will not take much time, don't worry. So we'll in the next lecture complete the week 3 as well as these 2 concepts. Is it fine?
Yes, ma'am.
I know we are going slow. I'm trying my best to go fast, but still. Okay. Any doubts? Other doubts? You can ask me.
Ma'am, we'll have these live sessions till our week 12, right?
Yes, that's the problem. Though I'll take one more extra to our lecture.
Okay.
13 weeks I can take. So 2 weeks are over, and then 3 weeks are over, and 3 weeks, I think 2 weeks are only completed, not fully also. So I'll try that 3rd week should be completed next. So that we are 1 week behind also in the last class I can, extra class I can cover that. Any feedback?
Prabha, we are taking effort to teach us. Thanks a lot.
And what about the other TA? Are you doing the same concepts, or like how the things are going? So that it shouldn't be clash. I should know that, like how the things are going in the other class. Yes.
And classes are exclusive, we can say. I mean, there is, of course, some concepts are overlapping, but a few topics, the other TA, the different topics she has covered, and you are covering different topics. I mean, I have attended last couple of lectures of you as well as other TA.
Okay. Chavi, I'm not allowed to take 2 classes per week, so it's not in my hand. I'm only given 1 or 2 extra class. Okay. Maybe you can mail me, Anusha, about this. Okay, once again, I'll write this. This is my mail ID. And this is my YouTube channel. I have written on the channel. Thank you so much, class. So we'll meet the next week, the same time, 6 to 8. Thank you so much.
Thank
Thank
you.
you, ma'am.